Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on the video, I'd like to ask you to please give it a thumbs up, hit the subscribe button, and engage with a comment below. In this video, we're looking at Unit 1, Constructions and Rigid Transformations, Lesson 4, Construction Techniques 2, Equilateral Triangles. The learning goal for this lesson is to identify what shapes are possible within the construction of a regular hexagon. We have two learning targets in this lesson. When we get done with the practice problems, we'll come back and review these and ensure you've learned everything you need to before moving on to the next lesson. Learning target number 1 says I can construct an equilateral triangle. This means a triangle where all three lengths are the same and all three angles are the same. Learning target number 2 says I can identify congruent segments in figures and explain why they are congruent. For the glossary terms in this lesson, we have circle. A circle is a line where every point on the line is the exact same distance from the center point. That distance from the center point to any point on the line is called the radius. For example, if we have a radius of 3, then that means every single point on that circle is 3 away from the center. The next glossary term is conjecture. This means you take a reasonable guess based on the information you have, and then you either try to prove that reasonable guess correct or incorrect. The third glossary term is inscribed. We say a polygon is inscribed in a circle if it fits inside the circle and every vertex of the polygon is on the circle. We say a circle is inscribed in a polygon if it fits inside the polygon and every side of the polygon is tangent to the circle. In other words, a shape with straight sides is inscribed in a circle as long as every corner of that shape with straight sides touches the circle and it fully fits inside that circle. A circle is considered inscribed in a shape that has straight sides as long as every side of the shape that has the straight sides is touching the circle and the circle fits inside of it. Our next glossary term is line segment. This is a set of points between two named endpoints. So rather than a line that goes on for infinity in both directions, a line segment has beginning and ends, and we name those beginning and ends. The next glossary term is parallel. Parallel means we have two lines or two line segments that never touch each other. Our last glossary term is perpendicular bisector. This is when you take a line, such as the dashed line here on the right, that cuts a line segment directly in half. And because it does this at a 90-degree angle, every single point on that perpendicular bisector is going to be the exact same distance away from the end points of the line that it cuts in half. So it's got to run through the middle of the line segment, and it's got to do so at a 90-degree angle. Now we can begin the practice problems for Unit 1, Lesson 4. This diagram is a straight edge and compass construction. Point A is the center of the circle on the left. So I'm going to highlight this in blue. And B is the center of the circle on the right. So I'm going to highlight this in yellow. They want us to explain how we know that triangle ABC is equilateral. So as we look at this, let's begin with the circle that has A at the center. We can see that line segment AC is a radius. We can also see that line segment AB is a radius. Because every radius of a circle is the same, this means that AC equals AB. So we know at least two of the sides are the same. Now let's look at the circle on the right, where B is the center. We know that segment BC is a radius. And we know that segment BA is a radius. And again, if these line segments are both radii on the same circle, then they are the same size. Now, if you look at these, AC equals AB, and AB equals BC, all three sides are the same length, therefore they are equilateral. So solving these types of problems is all about finding out what information has already been given to you, a lot of which is going to be prior knowledge from previous lessons, and then figuring out how to use that information that has been given to you to find that information they're asking you to provide. So here, if I know that two sides of the triangle are equal because they're both radii of the left circle, and then I know that two sides of the triangle are equal because they are both radii of the other circle, and I know that two of those lines were the same, now I can use that to show that logically all three sides must be the same. If you have any questions about this practice problem, please leave a comment below. Practice problem number 2. A, B, and C are the centers of the three circles. How many equilateral triangles are there in this diagram? The first thing I want to do is make sure you understand what the term equilateral triangles means. So an equilateral triangle is when all sides and all angles are the same. So, as we look at these, let's start with circle A. That's down here in the bottom left. We know that if you go from the center of a circle to the circle itself, that line is called a radius. So that means AH, AC, AB, and AD are all radius, so they are all equal to each other. So AB equals AC equals AD equals AH. Now let's look at circle B. Same thing. Every time we go from the center point B out to the circle itself, that line is going to be a radius, and all those radius are going to be the same length. So that means BF equals BC equals BA equals BD. And finally, we have circle C up on top. Every time we go from this center point C out to a point on the circle, we have a radius. And every time we have a radius, they are the same length. So we have CF, we have CB, we have CA, and we have CH. Now, if you look, what you'll notice is that we had AB on circle A and on circle B. We can see that we had AC on circle A and circle C, and we had BC on circle B and circle C. So if every line in the blue is the same, and every line in the orange is the same, and every line in the green is the same, and then we see that some of those lines are in blue and orange, or in blue and green, or in orange and green, then that means that all of these lines are the same length. So that means we have a triangle right here, number 1. We have a triangle here, number 2. We have a triangle in the middle, number 3. And we have a triangle down here on the bottom, number 4. Now, not only do we have the 4 small triangles, but if all of these smaller lines are the same size, then if I add any 2 of the smaller lines, they will be the same length. And I want to specify that it's any 2 line segments from the list that we made. With this in mind, I want to highlight these line segments on the right side of our list. If I were to add segments AD and AH, which would make this line segment on the bottom left, and if I were to add BD and BF, which make up this line segment on the right, and then I added CF and CH, which make up this line segment across the top, then I actually have a 5th equilateral triangle created from the 4 smaller equilateral triangles? So this means we have the 4 small triangles and 1 big triangle. So 4 small plus 1 big equals 5 equilateral triangles. If you have any questions about how to solve this practice problem, please feel free to leave a comment below. Practice problem number 3. This diagram is a straight edge and compass construction. A is the center of one circle, and B is the center of the other. Select all the true statements. So choice A says that line segment AC, which we see right here on the left circle, equals line segment BC, which we see right here on the right circle. Now, line segment AC goes from the center of the left circle out to the edge. That means AC is a radius. Line segment BC goes from the center of the right circle out to the circle. That makes it a radius. Because they are both radius, then they do equal each other, and A is correct. Choice B. Line segment AC, again, we see that up here on the left circle, equals line segment BD, which we see down here on this right circle. Well, again, we already said that AC was a radius. Now BD goes from the center point out to the circle, so that means BD is also a radius. Therefore, B is correct. These two line segments are equal. Choice C. We have line segment CD, which goes directly down the center here, equals line segment AB. Well, CD is not a radius, but AB is a radius. These are not the same lengths. So that means C is not correct. Choice D. A, B, C, D, which is the blue shaded region, is a square. A square requires two things. It needs to have four sides that are all the same length. Four sides, same length. That is true. However, the other thing that it needs is four right angles. And this does not have four right angles. Since that part's not true, this is not a square. Choice E. A, B, D, which is this bottom half of the blue shaded region, is an equilateral triangle. Well, AB is a radius. AD is a radius. And BD is a radius. This means all three sides are the same, so the angles are also going to be the same, and this is an equilateral triangle. And our last choice, choice F, CD, which is that line going vertically right down the middle, equals AB, which is the line going horizontally across, plus itself. So here's what I know. I know that AB is a radius. I also know that CB and BD are also radius. In a right triangle, the side opposite the 90-degree angle is the hypotenuse. The hypotenuse is always greater than either of the other sides. So this means that CB is greater than C to the center part, and BD is greater than the center part down to D. So CB plus BD is greater than CD. CB plus BD equals AB plus AB because they're all radius. Therefore, AB plus AB is greater than CD, not equal to. So F is wrong. If you have a question about this practice problem or any of the practice problems that we've done, please feel free to leave a comment below. Now, before we wrap up this lesson, let's go back, review the learning targets, and ensure you understand everything you need to from this lesson before moving forward to the next. So looking back on the learning targets for Unit 1, Lesson 4. Learning target number 1 says I can construct an equilateral triangle. So in your classroom, or if you're at home, practice this. Use a ruler or another straight edge. You want to make sure that your side lengths are the same, which will also create angles that are the same. So you can practice this until you get it just right. Learning target number 2 says that you can identify congruent segments in figures and explain why they are congruent. Congruent segments simply means they are the same. So in these practice problems, we were able to identify when line segments were radii, and then understanding that because the line segments were all radii, then we know that they are congruent, meaning they are the same length. And then we also understood that we could combine these congruent segments and create new congruent segments. I hope all of this has made sense to you. I hope that you found this video helpful. If you did, then in the bottom left of your screen, you should see a link to another video that YouTube thinks you'll find helpful. In the bottom right of your screen, you'll see the subscribe button for the channel. Please hit that subscribe button. Give this video a thumbs up. Leave a comment below, and I look forward to seeing you in the next lesson.